Today we're going to be working on Leetcode question number 164, maximum gap. We have been given the integer array nums return the maximum difference between two successive elements in its sorted form. If the array contains less than two elements, return 0. And basically we have to do it in linear time and linear space. So we have this example 3691, and the output is going to be equal to 3, because if you put them in linear, the sorted form of the array is 1 3 6 9, and either 3 6 group or the group of 6 and 9 is going to give us the maximum difference. The trick of this one is like that we have to do it without actually really like assorting them properly. What we're going to be doing is like we're going to be doing the bucket sort and put the different elements in a bucket, and then we are just gonna go through every single bucket in order to see like their successive element. So the maximum of the difference between the successive elements. So we're gonna initialize few things here. Basically our low is the lowest element inside the array, which is just gonna be equal to the min of the nums. This is gonna be a linear operation. We are good over there. High is gonna be equal to the max of the nums, and then you can have the length as n. So total length is equal to length of the nums. Now once we have that, what we're gonna do is like the edge case. We're gonna cover the edge case that let's say if the n is just less than equal to 2, right? If the n is less than equal to 2, there is one case, or the high is equal to low. In both of them, both of the things, we're gonna be returning high minus low, which basically means that in this case it's gonna be 0. Yeah, and if it is less than equal to this one, we're just gonna return the result. So that's gonna cover both of the cases. Good. Now first, the one thing we're gonna do is like we're gonna create a dictionary, right? And it's gonna be an empty dictionary in the beginning, which is like we're gonna say that our b is equal to the default dictionary with a list. And then we're gonna go through every single num. For num inside the nums, what we're gonna do is like we're gonna find an index, and we're gonna take that value. If once we have that index, we're gonna append that num to that. So basically we have a dictionary here where we're gonna find a particular index or a bucket index, and we're gonna append that number here. In order to find the index of that bucket, what we're gonna be doing is like there are two things. One is like if it's gonna be equal to total number of elements -2 if the num is equal to high. If it is the maximum one, right, it can be anywhere in the array. If it is that is the case, this is where we're gonna put it, because we know that these are gonna be the total number of buckets we're gonna have. So n is gonna be n minus 2 are gonna be the total number of buckets we're gonna have, and we're gonna be putting in the last one, right? Otherwise we're gonna calculate the index. For that we have to do is the num minus low multiplied by n minus 1, and floor division with the difference of high minus low. So this is the floor division, like this is the denominator here, where we are actually seeing that how much vast is the range. So depending on the vastness of the range, we're gonna every single time we're gonna say that okay, the num minus lowest one, okay, multiplied by the total number of elements, basically plus 1, we're gonna say that this is gonna decide our index of the bucket, and then we're just gonna uh, put it into the dictionary. Once we are there, now the candidates for every uh, like the for every range is gonna be equal to. So in order to calculate the candidates, what we're gonna be doing is like we're gonna say that the minimum and the maximum between that range, which is gonna go from the uh, basically from 0 to the n to the last one, we can actually do is minimum of b of I and maximum of b of I, right, for I in range of n minus 1 if b of if the so basically first of all we have an I, right, which is gonna go from 0 to n minus 1. So that is the case, right? Our I is gonna be then going like that, and then we're gonna say that okay, it's gonna go through that, and if that does exist, right, because look, the total number of buckets is gonna be different from the total number of index I going through all the elements. So if I is going through all the elements, we're gonna have different buckets, whether or not. So there is a possibility that the bucket does exist for that particular index, or there is no bucket which exists. So wherever it exists, we're gonna calculate the minimum of that and the maximum of that, and then we're gonna be returning. We're gonna be returning the. So first of all, what we're gonna be doing is we're gonna be zipping it. Zip the two things. We're gonna zip the candidates with the last element, sorry, one, and then this one. So basically we're gonna say that okay, one candidate has one number is gonna be aggregated with the rest of the candidates, right? And then we're gonna say that for x and y in this aggregated result, what we are interested in is the maximum of y0 minus x1. So we are interested in the maximum of y0 minus x1 whenever we have like the x and y's as the minimum of and the maximum of the inside the candidate, and we are zipping every single candidate from the candidates to the rest of the candidates one, and in the end we're going to be returning the difference between y0 and x1. Yep, and it did pass all the test cases.